All right, welcome back. Let's continue our discussion about addition, subtraction of matrices, some operations on matrices. So this time I'm introducing you to equal matrices. So when we say matrices are equal, these are matrices with the same dimension and their elements or their corresponding elements are all equal. Okay, so when do we use our understanding about equal matrices? So for example, if we have a scenario wherein we need to look for values of x and y. All right, so let's have these two equal matrices over here. So you can see that we have 2 by 2, 2 rows and 2 columns matrix. They are of the same dimension, and since they are equal, as you can see here, it simply means that each element, okay, each element, so this element is the same as this element. Okay, they are equal. Now, if you will notice, our variables x and y are included as expressions in some of the elements. Okay, so how do we solve for those two values? So let's start with x. Okay, if you're going to see, our x is in this element, so 3x plus 1. And to which element is this equal to? Again, these two matrices are equal. This element is the same as this element over here. So 3x plus 1 is going to be what? Equal to 16. Now, can we solve for x? Of course, we've been doing this for a long time. So solving for x, we know that we got to subtract 1. And then we will have 3x equals 15. And then dividing by 3, x is going to be equal to 5. As quick as that. Now this time, let's solve for y. And as you can see, y is right over here on this element. So if we're going to write our equation to solve for y, it's going to be 2y minus 1 is equal to what element? So it is corresponding to this one, which is negative 5. And like I said, when we isolate our variable, so let's get that one done. So you will have 2y is equal to negative 4. Dividing by 2 on both sides, y is going to be equal to negative 2. All right. So I think this part of solving or looking for the missing variable is easy enough as long as you are able to set up your equation. And again, those equations will come from the corresponding elements of the matrix. All right. Let's have a second example. And in this case, as you can see, you have different, you still have x and y, but they are like showing up in multiple places already. Okay. So for example, if you're going to decide on how to solve for x, it doesn't matter which part you choose. Either you choose this or you choose this, that's totally fine. What matters is you are going to set the correct equation. So let's say we use the x plus 1 element. Okay, so if we have x plus 1, it is equal to what? So this element is equal to 7. Okay, and from there, we know that our x is going to be equal to 6. Now, if you are not sure if you are right, then you can try the other. And you can see, if you replace x here by 6, 6 plus 3, is that really equal to 9? Yes, it is. Okay, so we can say that, all right, we got the correct value of x. Okay. Now for our y, now do not panic if you would see that they are both expressions. Again, when we say equal matrices, just set up the equation. So as you can see, we have on the left matrix, we have y minus 1, and it is equal to what? This corresponding matrix. So we have 2y plus 5. Now, are we capable of solving for y in this case? Of course we are. All we need to do is combine like terms, okay? So if we want all the y's to be on this side, so we subtract y here, we subtract y. So now we have negative 1 equals y plus 5. And of course, we want the 5 to move together over here with 1. So minus 5, and we can see that y is equal to negative 6. And again, you can double check with the actual expressions in each matrix and see if they will be equal. And definitely, both of them will be negative 7 in the end. Okay? So those are our equal matrices. Now, the next part is the multiplication. Now, with matrices, we have two kinds of multiplication. The first one is what we call as the scalar multiplication. So with scalar multiplication, you have a scalar or a number factor, and all you need to do is multiply that number to every element in the matrix. So let me just give you a quick example. So let's say I have the matrix -2, 4, and then 1, -3, and I have a multiplier, which is 3. So this is an example of a scalar multiplication. It's a number times a matrix. So again, from the rule here, all you need to do is multiply the scalar to each element. So we know that the product is going to be -6, 3, 12, -9. Okay? And you can also type this. You can also type this in your TI-84 and you will still get the same answer. Okay? So moving on, okay? Let me just clear out this. All right. So now, okay, of course, I'm not gonna be giving you just a simple number and then a matrix. So let's level it up a bit. So what I need you to find is the value of 4 times matrix A plus 3 times matrix B. Okay. Now do not worry about how to get this done. Again, everything on matrix, you can work with a calculator. So what are you going to do when you enter this thing in a calculator? So once you are on your calculator screen, you start with number 4. Oops, sorry. You start with 4, followed by your matrix. So 2, -1, 8, 5, -3, 2. Okay. Plus, okay, it's going to be 3. Now multiply with your second matrix. So that is what? -1, 0, 0, 3, 5, -2. Okay. And once you hit enter, it will spit out the answer to the sum, the sum between these two scalar multiplied matrices. Okay. So that's how you can get that one done. The other type of multiplication is the actual matrix multiplication. Okay, sorry, let me just get rid of all the other handwriting there. Okay, matrix multiplication is you multiply one matrix by another matrix. Now, I definitely explain the method, the actual multiplication process to third hour, but I am not going to expect you to actually do the work by hand. Okay. Again, everything could be done in the calculator, but it is also important for you to understand how those numbers are getting calculated by the calculator. Okay. So let me pretty much this is like a representation. I know it's kind of like a weird because you all have numbers. So pretty much what happens on matrix multiplication is that the row gets multiplied to the column. So first row multiplied to the first column, first row multiplied to the second column. And then you go second row multiplied to the first column, second row multiplied to the second column. So that's why you will see that those are the representation in there. Okay, now I know it's kind of like messy if it's like this, so let's check it out with actual numbers. Okay, so let's say we have matrix A with 2 times 2, 1, -3, 0, and matrix B. What is AB? Now it's going to be really quick if you do this on a calculator, because all you need to do is type this matrix. You can choose to press the times button, or you can actually add the second matrix right away. You can already like type in the next matrix and the calculator will recognize it as the multiplication. Okay, so to explain how the actual multiplication works in the background. Okay, so what happens is we will multiply 2 oops, sorry, I did not activate the pen, my bad. Okay, there we go. So we will have 2, so this one first. Okay, it's the first row multiplied by this. Okay, so that's 2 times -1 plus, okay, multiply 1 by this second element here. So it's 1 times 0. Okay? Now, for you to get the second, for the second column, you can multiply 2 times 3 plus 1 times 4. Okay? So now that we have the product's first row, we go now to the second row. And for us to be able to do that, we multiply the second row to both columns, okay? So on the second row, we will have negative 3 times the first row, which is negative 1, plus 0 times 0, okay? And then the next column over here is negative 3 times the second column 3 plus 0 times 4. Okay? And so if you simplify all of this, so this is actually the matrix, okay? And you will be able to simplify our matrix. So that would be negative 2 plus 0, that's a negative 2. You will have positive 3 plus 0, which is a 3. You'll get 6 plus 4 and a 10. And then negative 9 plus 0, which is a negative 9. So eventually, you will see that this is actually the same product that you will get on your calculator when you enter these two matrix and multiply them. Okay? So again, I'm not going to have you do the long by hand multiplication. I just wanted you to understand how those numbers came out to be. Okay? So that's everything that you need to learn right now about the operations on matrices. So please make sure you get some practice on the handheld calculator, get the assigned work on Math Excel, and I hope you go back to this video if there are any clarifications or you are confused on something. Okay? All right. Bye.